Okay, now we're going walk through another chapter, and hope we can finish this chapter before 12 o'clock. In this part, we're gonna teach you how to create a user frame in our DIATwin, and we have two different kinds of methods. First, we're using 3 points as a real machine, and second, we can use the snap function. Okay, now we're gonna walk through how to create a user frame. Before that, we kindly ask your help to change another model. Can everyone help to open another project? This one, file, open file, and don't save. To import the past demo kit over here. Past demo kit. It will take some time, so because the robot base okay. Originally, if we using the real robot, we always use 3 points to teach a user frame, right? Right. Is that correct? And so normally we can teach the first point as an origin point. And secondly, we can set a point to record the x direction to define the x direction over here. And the third one is for y. It's for y direction. So if we want to create an orthogonal to the word, we can use this kind of method. And we have a quick introduction about it. First, we have to select a user frame we want to use. Let me just directly use a demo. Here, we go into the job mode, and we can find that there is a user frame 1 over here. And we couldn't modify the user frame 0 because it is a default value of the robot. We couldn't modify it. So please have to set like UF2 over here. We can check it. Here's the origin point of UF2. But if we want to modify it, we can click the move user frame here. Okay. When we go into this page, there is a 3-point method. We click it. Now we can use the job by snap function to create a user frame. For example, we can set the position here. Of course, the Z direction have to be modified here. And now we gonna record this position to the origin. Secondly, we can set the X direction here and fill in. And finally, we can set a Y direction, like over here or here, whatever. Ready? Now we already teach the 3 points. And apply it. And move the robot back to the home position. Okay. Now we can find that if we show the user frame 2, it's already established at this position I want. So everyone can try it out. Yeah, I have a description about above. So we can enter in the program and job mode, and there's a move user frame.
Okay. Yeah. Here's the user frame. And choose pick up one.
There's a you have to choose another user frame. In fact, we have another way to establish the user frame by 3D World, because we are using a 3D World. We are using the virtual environment, right? So we have we can know that every single point on the 3D World on the virtual machine. So we can use the snap function to directly click a point to establish the user frame. So in our virtual world, we can directly use like this. We can assign UF3 and use the snap function. When we click snap over here, we can directly choose a point and modify it with the orientation, something like this. Okay. And the next part, we only have 3 parts left. So for the next part, we're going to introduce the path statement, and the path statement. The path statement is for a path generation tool that we can use in CAD file to generate the trajectory and the path that robot have to go. So this is a simple introduction. We are going to use this kind of method to select the point or the curve on the 3D world and then generate the robot movement by this kind of feature. So we don't have to teach the point one by one, and we can directly use the like this kind of CAM tool to generate the recipe. Okay. This is how we generate the path statement. First, we will use the same model, same as morning, and there are some product in the environment, and like fan housing, like speakers. So we gonna use this 70 robot to with the welding torch tool to generate each statement. And before we going to create a path, we have to create a user frame on this product first. So please remember to establish the user frame before we using the path statement. And there are some this is a step of how we create the path statement. First, we can choose the product we want. For example, in this speaker, I can choose this speaker user frame. And second, we can go into the path statement mode by clicking these features, like click the curve from this side, and we can generate the path from it. And secondly, we can trimming and deselect or multi-select the point, or we can use the control with the left button to cancel the click. And here are some. Okay, let me show you. First, we going like if we want to generate this circle movement, we can go into the jog mode. And then there's a path statement over here. You can enter in. And now you can, we already enter into a 3D features detection mode. So we can find that, okay, there's different normal vector when we approach from different side or different surface. So the normal vector will be affected by the surface we go through, and later on we can just multiple select to okay, we can multiple the curve like this, and yeah, that is the first step of how to create a test at least. And if you don't want a part of the curve, you can press Control button with the left button, so you can cancel the selection by this move. Okay. Oh, sorry, I made a mistake. Sorry. Sorry. If I want to create a path on this object, I have to select this like fan housing, and then select the user frame container we create, so that we can generate a path. Sorry, I forgot to change another user frame. You have to choose the component you want and the user frame you want, and then select the path on it. Okay. So we can generate the robot movement by this kind of manipulation. And it's just a quick demo. That everyone can try it to create a circle on this, okay, see, fan housing. Yeah, fan housing. And if you cannot let the robot run the simulator, or there are some error message like this out of the position, I will teach you how to solve this problem later. Okay, let me walk you. Everyone will find that there are some functions, and also the like offset, like interpolation. And let me walk you through this kind of function. First is the offset. Yeah, if we create a path like this, like a circle path, and we want to make the offset of it, we can directly key in the value from normal vector, side offset, or angle offset. For okay, the normal side is with your right hand, and there is a normal side is represent the z direction. So if we generate a path that we modify the normal side, it means that we can make the point go upward. And if we modify the side offset, it means the y direction. So usually, if we create a path of a circle, the side vector will go into the middle of the circle, right, like this. And so, if we adjust the side offset from positive, it will go inner to the circle. If we adjust the side offset in negative, the circle will be the outer, will be bigger. And also the third one, the angle offset it means like there is a theta angle over here within the normal vector. So if we adjust the angle offset, it will change the theta angle over here within the z axis. So if we change it, it will be like this or like this. Okay. This is the first part, offset. And second one, this is for interpolation, which means the density of the robot pet. We all know that if we interpolation, if the interpolation is the amount is more, then we can have a more accurate result of the curve. And the linear deviation means that the point between the distance between the how can I say this part, it will orthogonal with the direction with the path. So if the distance is too large, there will be the path will not like a curve, not like a circle. And also if we adjust the maximum distance over here, we can find that okay, if we choose like 10 millimeters to 1, we can find that okay, the interpolation point will be increased by this maximum distance or linear deviation or angular deviation. The third one is orientation. I think I just stop by here for a while, so everyone can choose a. I would recommend you to choose a circle like this, pad over here, so you can choose the speaker and select the user frame. Now we can have like on the curve over here, so we can find out the difference between the density and also the offset. Like this, if I choose the initial point, initial line over here, the start means that the start means the starting point, and the direction goes here. But I don't want to do that, so I can press the reverse button over here, and then click the next one. Okay, so now I have created this kind of statement, but I can try some offset like we say. the normal vector will affect the z-axis, right? So if I want to go upward, I can minus 10. It will be like this. Okay, that's 2. Okay, minus 2 is fine. Okay, so if we adjust the side offset around like 5 millimeter, we found out, oh, okay, there goes the outer, sorry. And if we modify the angle offset by 45 degree, I think there is a 45 degree offset between the normal vector with the current one. Okay, so if we want to have more points in this area, I can directly modify the linear deviation or also the angular deviation. So you can find that, okay, during the curve, the interpolation point will be increased. And this is the most intuitive. If we modify the maximum distance, we can find that, okay, the linear will be the point of the interpolation point will be increased. Really intuitive. Okay, let's try it out. Because the direction you can create the new thing, and yeah, here you can find the z-axis in above right. So currently the forefront on the robot is like this. So we should use the another way, like across axis to minus z. Or you can use the apply to inverse surface with surface normal vector. Yeah. So you find that the direction will be changed. It's because the direction is still above right, but the forefront will not be changed if you modify this one.
I have moved the one, but very good and move it.
You want to please call out to you?
I say I have a bit that the first element is one, but it's not very moving for something.
I mean, we not think.
This
is a part of the scenario.
If follow it by
if you see the 4 point, you will find that this is the third scenario out of chapter 4. Yeah, chapter 4. The third one. Okay. Is there anyone have question?
ตัวเลขทั้งหมด
ทำผิดขึ้นอยู่ใช่ไหม
Okay.
ทำผิดขึ้น
โอเค
Okay. Let's move on. And for the third part, we call it orientation adjustment, which means that which axis you want to approach with this curve. Normally if we create a point, the normal vector will be above from the surface, right? But if our tool, the coordinate of the tool is not orthogonal with this normal vector, we have to do some orientation adjustment. For example, if we create a curve like this, the z-axis is above. But if we want to use the tool frame, which is not above, so we can use the inverse the surface normal vector over here. So you can find that the direction will be go down. And of course, if you want to do another kind of process, you want to let the x direction follow with the curve, or if you want to use if you want to process the outer line or the inner line, you can use this kind of method to adjust the orientation. Like if we want to move a circle like this, we can choose to use normal vector. But if we want to use the tool process like this, maybe we have to use from the movement direction. So you can try to modify the align to properties. You will find that they have 6 types of the orientation you can choose to process. And okay, and the other part is there is a radio button called align to second. What does that mean? It means if we choose the curve, the orientation will follow with the normal vector. But if we choose to current pose, we have a demo here. If we choose the current pose, you can find that the tool frame is currently look like this. So all of the points will be same as this kind of orientation, this kind of posture. So if you want to align with your tool right now, you can choose to use the current pose. But if you want to follow the CAD feature or the orientation of the feature, you should use the curve over here. Yeah, it depends on the tool frame we choose right now. So if we choose another tool frame, like choose to another static tool frame, it will be shown like this. It will be aligned with the current tool frame position and orientation. So it depends on your simulated situation. Okay, so if there is anyone who cannot produce a robot movement, and you will find that there are so many point position out of range or position is out of reach of the robot, you can adjust the align to or also the current pose to try it out.
我想可以。我觉得。Inverse backward. We already inverse this backward, so if we still it would go out. That's still be versus the temporary will be from wait, the position is still the same, so I see. It is based on the Wolfram. Yeah, so minus squeeze means that it's based on this line and possible minus string.
像我那set 都飞秀，我给你把它反过来，不是人家头一直射不了。这个是要讲，因为就那个跑这个的话，还是会很有传的。
那你怎样去别地方把它送钱？
哦，对，就是这个。
对，就是这个。日本只有当前这个状态，那你要改的是你刚刚设定的这个 OK， 可以，要改。Because the curve, you have to choose it again because the vector, the direction of the vector is different. Because the normal vector, the red arrow will be impacted by the base. If we go through, if I go from here, whereas the arrow direction is different, right? But if I go from here, that is the direction I want. Okay. So you have to be careful when you choose the line from which surface you go through.
Okay. And there are some features to adjust the curve. First one is reverse. So if we click the path that we don't want we want to reverse it, we just click the reverse. Or we might encounter a problem that the curve is not continuous, so we have to modify it after that. And we also can drag the start point and also the end point in the 3D world, so we can trimming the position we want to start or stop the trajectory. Okay, this is reverse. And second one is trimming. Trimming means, of course, you can modify the start point by drag the star icon over here to trimming this path. Yeah. And the third one is frame selection. Frame selection means you can use, you can choose, you can directly point to the point, and then you can find that there is a frame in the 3D world. It represents the current orientation of each point. And of course, you can use multi-select by here and to select 3 or 4 points and see that, okay, the orientation of each position. And if we want to modify just the curve, we can multi-select the curve and like modify the orientation of RZ or RXYZ. But you have to be careful that if you using the dragger to manipulate, it might be affected by the final point you choose. So the position will based on the final point. The orientation will based on the final point. So if you modify the RXYZ, you will find that the position will be weird. You have to be careful about it. Yeah, and if you modify the y-axis, you can find that the circle will be bigger or smaller. Okay, let's give a practice. Please help to create this kind of movement at the right hand side. I would say it is easier to have a curve at this part, so you won't face any kind of out of range problem or kinematic singularity, something like that. Okay, so we have some description over here. Please help to create a user-friend container at the product first. Okay, how to create a user-friend container? We can click in the modeling. We can click this model. Okay, it is called the test plate. And secondly, we can right-click on behavior to create a user-friend container. For example, I want to make it within this point. I can use the snap function to create a user-friend container. But be careful, user-friend container is just a container. It's not the real one. So we have to actually create a user-friend, maybe on the same point. Okay. That's the whole process of the first one. No. Okay. So after we have created the user friend in this product, we can find that, okay, if we create another test statement, we can find there's a test plate over here. But if we didn't create a container, we couldn't find at least I couldn't find the corresponding component over here. Give me a second. Okay, if I create a user friend, I can choose the test plate component here, and I can select the user friend I just create here. Okay, so I can directly choose some point. We just have to use the outer line. We don't and yeah. Maybe modify the angle offset from -30, I think. And I don't need that much interpolation point, so I can modify the maximum distance. Okay. And everyone go through this part. Everyone asks about how to modify the path, right? How to, if we finish the editing, how can we modify the path statement? We can right click the path statement and select all. Right click and select all. And later on, you will see there's a visibility in the tree, which is, choose it. You can find that the point in the path statement will be expanding. And you will see that, okay, there are so many points within this trajectory. Okay, so if you want to modify the offset of the position, you can just you can just use the object to -5, I think. -5 is not a good decision here. -5, -10, you can get a different kind of result. To based on the points to do the offset. And also you can adjust the orientation by 45 degrees. And be careful that if you're using the dragger will be created at the final point you select. So if you're using dragger, it will be like this. It will depend on the final position you choose to rotate the whole path. So if you want to only adjust by themselves, by the points themselves, you can use the object mode over here to if I want to make the z-axis to rotate 45 degrees, I can rotate with the arc's direction. So yeah, so now the x-axis will be affected by rx rotation. So once again, if we want to modify the orientation, we can multi-select. We can use the select all and visibility in tree to select every single point in the path statement. And later we can use the object mode to adjust the orientation or the position. everyone can try it. I think some of them mentioned that I want to modify the tool orientation. For example, the initial status will be like this, right? And I want to let the robot, the tool with 180 degree offset, so we can use the same function by clicking the path diamond, select all, visibility in tree, and we can use the object to rotate the position from RZ to 180 degree, so that the position will be, the orientation of the robot will be changed by this. Okay.